In this video, we're going to look at the mean and median of a probability distribution. So we're given a probability density function of e to the negative 3 minus x over 1 plus e to the 3 minus x quantity squared in that denominator. We're asked to verify this really is a probability density function. We're asked to find the probability that x is between 3 and 4. We're asked to graph the probability density function and asked what it appears for the mean to be and what it appears for the median to be. All right, so to check whether or not something is a probability density function, we have to integrate the probability density function over the entire real line, over the entire interval minus infinity to infinity, and see that we get 1 for our answer. This case, in this problem, this function is defined for all real numbers. We don't have a way to cut down the interval here. This is defined from minus infinity to infinity. So I really do need to integrate from minus infinity to infinity. This is doubly improper with the two infinite limits of integration. So I'm going to split it into 2 and evaluate each separately. Ordinarily, when we see this, we split it at 0, but there's nothing special about splitting it in any particular place. I'm going to choose to split it at 3 only because notice that if I plug in 3 into my exponents, I get e to the 0, which gives me a 1. It makes things a little bit easier to simplify. So we'll replace each bad limit of integration with a limit. So we get, first one we get the limit as b goes to minus infinity, and we'll put that b as the lower limit of integration. The second one will have the limit as c goes to positive infinity and have the c as the upper limit of integration. Now this integral may look nasty, but it's not too bad. It's just a simple u substitution. Let u equal what's inside the squaring. So let u equal your 1 plus e to the 3 minus x. The derivative will be a negative e to the 3 minus x. So we'll get that's our du times the dx there. So all we're looking at is integrating 1 over u du. Right? Well, excuse me, 1 over u squared du. I missed my squaring there. When we anti-differentiate the 1 over u squared, we get a negative 1 over u. Notice that negative in front of the 1 over u will cancel out the negative that we need to adjust for the du. So that's why we just have a positive 1 over 1 plus e to the minus 3x as our antiderivative. So again, we did our u substitution. Ended up with du over u. There would be a negative that we would need to adjust for, but that negative goes away because when you integrate 1 over u squared, you get a negative 1 over u. So your negatives will cancel. So now we plug in our endpoints here. The first one will get 1/2 minus 1 over e to the 3 minus b. The second one will get a 1 over 1 plus e to the 3 minus c minus 1/2. I missed a 1 plus here. There should be a 1 plus in front of this e to the 3 minus b piece. My apologies. There should be a 1 plus here. Turns out it shouldn't matter. Okay. So even if there's a 1 plus here, as b goes to negative infinity, we're going to plug in bigger and bigger negative numbers here. E is going to go to a big positive number. Adding 1 is still a big positive number. So 1 over that is going to go to 0. So that limit just turns out to be 1/2. Over here, if I would have forgot my 1 plus, it would have mattered. Over here, as c goes to infinity, we got e to a big negative number. That gets really close to 0. So this limit turns out to be 1, but we still have the minus 1/2 there. And if we simplify, we really do see that we have 1. So for part B, the problem asks us to find the probability that we're between 3 and 4. Well, that's just a matter of integrating the function on the interval from 3 to 4. In the previous part, we already found an antiderivative as 1 over 1 plus e to the 3 minus x. We need to plug in our endpoints. When we do that and simplify, we get this particular value. It's probably just as easy to put that in a calculator and get a decimal approximation, which I did here, and get 0.231. But again, to find probabilities, when you have a probability density function, you just need to integrate the probability density function over the interval that you're given. All right, so in this next parts, it asks us to guess what the mean and the median are. Okay, so we look at the graph of this distribution. We notice that it has a bump at 3. So it's likely that the mean and the median are both 3 in this case. Because, again, if we're symmetric about this line, that means there's just as much here on the left as there is on the right. And this also should split my distribution in right in half. Remember, a median is where you split the data in half. Half of the data should be below, half of the data should be above. That should be your 50% line. Okay. All right, so we guess that the mean and the median are both 3, but let's see if we can figure that out. We're going to use some properties of the function here. We notice that the graph is symmetric around 3. So let's shift the graph 3 units, okay, left by putting in an x plus 3. In particular, that's going to shift this over to the origin, and then I'm going to check that it's an even function. So that's what I'm doing here. So shift it over 3 units to the left. Here's our new function, e to the minus x over the quantity 1 plus e to the negative x quantity squared. To check that it really is even, we'll plug in negative x for x. It gets rid of those negative exponents. Doesn't look the same as we started with, but I can make it look the same as we started with by essentially dividing top and bottom by e to the 2x. Or, well, the way I've got it is multiplying top and bottom by e to the negative 2x. And go through some nice little algebra simplification, and I do see that I end up with the same thing I started with. So in particular, when we've shifted this graph over 3 units, we created an even function. So that means that that original graph is symmetric around the line x equal to 3. All right. So that means that our area to the left of x equal to 3 is the same as the area to the right, and that's exactly what we would need in order for the median to be 3. All right, so for the mean, we notice that the easier way to notice is just notice that that function g of x that we created, that's an even function. So if I multiply it by x, I get an odd function. We also, way back on the first slide, we showed that that doubly convergent integral that doubly improper integral converged. All we did was shift everything over 3 units to the left, so that integral of g of x would also converge. Since it converges and we have an odd function that has a symmetric about the origin interval that we're integrating over, we know that we integrate an odd function over a symmetric interval, we get 0. And that's going to help us get what the mean is. All right, so remember our mean here is, the definition is to integrate from minus infinity to infinity of x times the PDF, the probability density function. Let's shift everything over to left 3 units. Well, that's just a simple substitution. And our du, if I let x equal, think of it as a u substitution. If I let say u equals x minus 3, then x would be u plus 3. I kept it as an x, but it doesn't matter if I keep it as x's or u's. Shifting everything 3 units to the left isn't going to change my integral at all, because I'm just integrating over the entire real line. F of x plus 3 is g of x. Now I can distribute my g of x and break my integral up. We notice that the integral from minus infinity to infinity was 0 for xg to g of x dx. That's what we were talking about up here for it being an odd function. And if we pull out the 3, this is essentially integrating f of x over the entire real line, which we said was 1. So 3 times it'll just be 3, and we really do get a mean of 3 like we anticipated.